So Peter Robertson is a computer scientist at Cambridge, and he's co-PI with me on the Templeton Research Grant on the implications of advances in AI and robotics. So it's been a pleasure working together. And his topic is ethical implications of emotionally responsive machines.
Thank you. Thank you very much. Wait till later, if at all. You're probably wondering, I'm a geek. And what are geeks doing talking about things like ethics and emotions? They don't sort of subjects that you don't normally associate with each other. You know that the computer scientists are not famed for their social skills. The extrovert computer scientist is the one who looks at your feet rather than his own when he's talking to you. So why am I interested in emotions? And the answer is I'm actually interested in communication between people and machines. And we can learn a lot about that from the way that people communicate with each other. And when people communicate with each other, it's not just what I'm saying, but it's how I'm saying it that matters. And we use social signals, things like facial expressions, tone of voice, body posture and gesture, to convey things about what we're feeling as well as what we're saying. So if you're lucky, when I'm speaking, I'm looking at your faces, trying to understand whether you're interested or bored, confused or understanding, and I'll change what I'm doing accordingly. And it's just a normal part of social communications. And people who can't do it are at a social disadvantage. It's people with autism spectrum conditions. Well, in that sense, computers are autistic. And can we do something about it? Well, maybe. And that's what I'm going to talk about and show you some of the work that we've done on trying to give computers some sort of emotional awareness, and then touch on whether this actually has implications for our understanding of machines and indeed our understanding of people. And if we study emotions, the ideas go back a long way. We can go back to Darwin's work, if not earlier, but Darwin did a lot of scientific study of emotions in the 19th century. And he was interested in knowing if these facial expressions of various mental states were actually universal, because if they were, that would be an indication of the strength of evolutionary forces. There's an evolutionary advantage in understanding what somebody's thinking by being able just to look at their face. And Darwin collaborated with Guillaume Duchenne de Boulogne in Paris. Duchenne had also been studying facial expressions and had collected photographs, notably of the tramp you see on the right-hand set of pictures here. It's actually one of the earliest scientific works to use photographs, and had this man expressing different emotions in the photographs and also sometimes attaching electrodes to his face to activate the muscles to simulate the expressions of, for example, pleasure, and to see if that induced pleasure. It didn't. But the photographs were very useful, and Darwin actually acquired a set of them. These are beautiful photographs, about so big. We have Darwin's collection in the university library here. And Darwin used them to see if people had a consensus view as to what the emotions were that were expressed in these photographs. And the way that Darwin did it was by crowdsourcing. Now, crowdsourcing in the 19th century is a bit different from now, was a bit different from now. Darwin's technology was to invite people round for dinner at his country house, and over drinks before dinner would pass the photographs round and ask people what they perceived in them. And he put the answers into a spreadsheet. These are the spreadsheets. We actually have these in the university library as well. And you'll see columns down the side with the names of the guests, Lord so-and-so, Lady so-and-so, across the headings of the columns, the numbers of the different pictures, and entered into them the person's understanding of what that picture depicted. And here we see 10 of the pictures, and the top row of labels are the consensus views that Darwin detected when people looked at these pictures. Well, we actually repeated his experiment a few years ago using modern crowdsourcing on the World Wide Web. We put these photographs online. We got about 20,000 people to say what emotions they thought were depicted. And again, we saw the same sort of consensus view. It's the second row of labels. And modulo slight changes in language, we can actually see that, yes, they were universal, and yes, they're still interpreted the same way today. So what this tells us is that we do have a universal language of emotions that's displayed in people's faces. And maybe we should do something about it. Now, actually, of course, we know that this is true, or at least people like Disney know that this is true. And for those of you who've been to see the film Inside Out, will have seen these animated characters that are, as it were, performing inside the head of a young girl, or indeed all the characters in the film, who are expressing these emotions, and they're controlling those emotions in her body. We see sort of anger, disgust, joy, fear, and sadness. And in fact, these are more or less the emotions that Darwin was studying, and actually more seriously studied in the 1960s by an American psychologist, Paul Ekman. Although there is a sixth one of these emotions that Ekman studied, which is missing from Disney's work, which is surprise. So no surprises in Disney, it would appear. Well, these basic emotions are something that's important for evolutionary advantage. It's clearly important to know if someone's disgusted by what they've just eaten, because you probably don't want to eat it yourself. You'd like to know if someone's angry, because that will probably moderate the way that you behave towards them. And this idea of a mind in the face has been studied more subsequently, particularly by my colleagues in the Autism Research Centre here in Cambridge. Simon Baron-Cohen does a lot of work on trying to understand the pathology of people with autism who can't understand these expressions. And these facial expressions really are an important part, as well as these basic emotions that Darwin and Ekman studied. There are other more interesting mental states, things like understanding and confusion, which have been less studied, but actually turn out to be rather important for computer interactions. You want to know if the person using a computer is confused or understanding. And there's a much larger vocabulary of potential emotions. And these are actually slightly more difficult to understand, these complex mental states. The photographs here of an American Hollywood starlet of the early 20th century, a woman called Florence Lawrence, or the Biograph girl as she was, who in 1909 was making 3 feature films a week, a level of productivity you don't see in Hollywood nowadays. Now, the reason that she could be so productive was, well, the films were only 20 minutes long, because that was as much as you could fit onto a reel of film, and they were silent films, so she didn't have to learn her lines. But the fact that they were silent meant that her facial expressions were extremely important. So this advertising card that she had published shows the huge range of facial expressions that she could convey on film. And you can't quite read the labels, but they're fairly convincing, although there is an interesting observation. The one in the top left-hand corner is labelled piety, and the one in the bottom right-hand corner is labelled sadness. And I think they're indistinguishable. And that probably says something about the morals of Hollywood starlets in 1909, as much as today. In fact, what it says is something slightly more subtle, that some of these mental states you can't actually identify from still pictures. Even people take 1 or 2 seconds of evidence in order to be able to understand them. So there's something rather important about this language of emotions expressed through the face. And I'd like to suggest that it's something to do with, from a Christian perspective, to do with the way that we were created. We were created for relationships. If we go back to the beginning of Genesis, the thing that we see there is that God cares about relationships. God cares about relationships between people. So it's not good for the man to be alone. I'll make a helper suitable for him. And God cares about relationships with him. God walked in the garden with the people. Now, these are both relationships that were broken at the fall, and we'll come back to that at the end of the talk about perhaps what the implications are of that. But it seems that this idea of relationships is something that is peculiar to humans as a species, our relationships with each other, and particularly our relationship with God. And that relationship is communicated through this understanding of other people's feelings expressed in their face. So as a technologist, it seemed like we ought to be able to replicate that. We can understand a bit about computer vision and a bit about these facial expressions. Let's see if we can understand them automatically. That's a slightly naive view, but that didn't stop us. So what we did was to essentially point a webcam at people's faces, track feature points on the face, and from those you can make inferences about where various parts of the face are. You can make inferences about how the muscles in the face are moving, and this gives you a coding of things called action units, which is a language used by psychologists when they're coding people's expressions in video. So things like head up, head down, mouth open, eyebrow raise, whatever. So there's a language of 50 or so of these action units, and by a little bit of arithmetic you can work out what they are. And then you can work out what's happening over a sequence of these. So a sequence of head up, head down actions is a gesture, a nodding gesture. And then building on that, a nodding gesture combined with smiling might well mean agreeing, whereas a nodding gesture without the smiling might mean falling asleep. And so you can build layers of analysis up and finally understand what someone's saying. So if we have somebody who's meant to be agreeing, this is a woman that we asked to act as if she was agreeing, you'll see nodding and smiling happening. And what you're seeing on the computer screen here are, on the left-hand side at the top, various bars showing the gestures she's making, and across the bottom, traces showing the probability of different mental states. And you see there's a little pause at the beginning. This system, like people, takes a couple of seconds before it can begin to form an opinion. And then we see a strong trace of the red, which is agreeing. And then, in fact, if you thought she'd done enough of it, and we see little bursts of green, which is interest, yellow, which is concentration, and then she does a bit more acting. So if I actually show the video again, you'll see she's smiling and nodding, and we pick it up. When she goes a little bit quiet, we get a drop in the probability, carries on, and then at the end of the video, there's a slight pause, and she realizes she meant to do a bit more acting, so she does a bit more nodding and smiling, and we get another burst of red. Well, sorry, that's a slightly unscientific way of explaining what we do, but it is actually quite a reasonable tool for distinguishing between perhaps half a dozen different conditions which together maybe encompass a tenth of the entire range of mental states. So we don't have something where you point a camera at someone and say what they're feeling, but what we can do is distinguish a small range of conditions that together form only a small part of the space of emotions. And in fact, this has been used by my student who did much of this early work. She has a company in America which does this sort of analysis, only a much simpler analysis. Well, in one way simpler, she's just trying to see whether people are pleased, something called valence, whether they're unhappy or happy, and can monitor this in real time. These are computerized machine learning systems. They learn from examples, and the thing that she's been able to do with commercial funding is to get tens of millions of examples of pieces of video and analyze them and build up a better machine learning system. And the company now does work, for example, for advertising companies who show previews of commercials to a small audience. This system monitors the audience and checks that they're pleased at the appropriate points in the commercial. It also has been used to monitor responses to things like presidential debates in America, where you can measure the participants' political views by a questionnaire and then monitor them as they listen to the debate, see when they smile, when they frown, and then measure their political views at the end, and you see a correlation between the change in their political views and the points in the debate when they were amused. So this is quite a powerful tool. It's something that allows you to understand something about what the individual is thinking, which is why there are ethical issues here, but actually it works much better. It doesn't give you an instantaneous reading. It's better if you're averaging either over time or averaging over a large number of people at a single time. So the audiences for the commercials, you have a large number of people, and you make quite good instantaneous averages over them. And for an individual person watching a debate, you accumulate information over half an hour or an hour, and that gives you a quite good indication. Well, that's one tool for measuring the face, and essentially using a language of discrete conditions, so things like pleasure, surprise, anger, disgust. There's another psychologist called James Russell who did an analysis where he got people to group lots of emotion words according to their similarity or dissimilarity. So words that are similar would be grouped together, words that are different are spread out on the table. And he did a mathematical process that allows you to analyze this, and came up with this depiction of where various words lie in a two-dimensional, or indeed even a higher dimensional space. And interestingly, the horizontal axis here is this axis called valence, from negative, so bad feelings, to positive, happy emotions. So you see it getting depressed and gloomy on the left, up to satisfied and content on the right. And the secondary axis is something called activation, going from passive at the bottom up to active at the top. And so a fairly neutral emotion that's low activation is something like sleepy, and something like excited is a positive emotion that's also got high arousal. So this is a different way of measuring emotions. It sort of plots them in this space. There are other axes that people talk about: potency, whether it's weak or strong; tendency, whether it's an inward or outward. But the picture is rather misleading here. To suggest that these have pinpoints in some coordinate space is deeply misleading. In fact, if you analyze videos of people expressing emotions, what you see is you get whole clusters that cover large swathes of this area in this chart. And actually, it's much more complicated than this makes it look. And it's actually not a particularly useful language, but we can still measure it. And so here we see a more recent system that we've built in the lab, where we, again, point a camera at somebody's face. We find the head in the picture. That's a little version you see at the bottom. We've normalized it so we can then do various analyses over the textures in it, so we can see the muscles that are moving. We've got the action units across the bottom, things like brows raising, smiling, whatever. And occasional words for discrete mental states popping up if we see them strongly enough, and also the points moving around in the valence arousal space. The camera tracker that you see here was developed by this student, Tadas Baltrusitis, who's now, or also did the work that on the system that led to SimSay that you were hearing about yesterday. So it's, in fact, the same tracker that he developed is used by them. And this is quite an interesting tool that allows us to monitor people's feelings in some sort of general sense. Now, in fact, it turns out that the face is very much an indicator of valence, happiness, sadness. It turns out that the voice is a good indicator of arousal. So various things in the voice, the energy, the pitch, the tempo, can tell us something about somebody's mental states. The trouble is, when you're analyzing voice, there aren't the same sort of simple markers that there are for the face. There aren't muscles that you can identify working. And in fact, it turns out that you can't really pick out an individual characteristic of a voice signal that lets you pinpoint the emotion that's being expressed. And instead, what you can do is take two different conditions and identify some metrics that distinguish them. And then you can take another pair of conditions and it'll be a different set of metrics. So you're quite good at separating pairs of conditions, but not pinpointing them. So what we have to do here is do all the possible pairwise comparisons and then sort of combine the results in a voting system. And that actually can then give you an indication of the most likely mental state, and indeed, if there are several occurring at the same time, which of course naturally happens. So you can do similar analyses of voice as well. And of course, body posture and gesture is important. Monitoring body posture and gesture is a bit harder. You have to put on this rather exciting leotard with reflective dots on it. And then we use a motion capture system, rather like the ones they use in film studios. And you have differences in your posture if you're upbeat and lively or downbeat and sad, as you see here. This also you can analyze and again, by the same sort of techniques of training by example using machine learning, can identify emotions in a person. But the problem here is these tend to be personal. For facial expressions and voice, they're pretty well universal. And in case of voice, even cross-language to some extent. Body posture is, and expression is very personal. Some people are just naturally animated, some people are naturally still. And you have to sort of tune it to the individual to get reasonable understanding. But we've actually used this in practical cases for a tool that tried to teach children with high-functioning autism spectrum conditions about emotions. And they play various games, one of which is trying to act emotions. And we use a variety of these systems, monitoring facial expressions, voice, body posture, and gesture, to give them feedback, to teach them how to act emotions, because that also teaches them how to recognize emotions. And this is an example of our tool for teaching facial expressions. Essentially, the picture top left is a video that's played of someone acting an emotion. Picture top right shows somebody trying to replicate it. And then we get various diagnostics that say you needed to smile more, you needed to open your mouth more, or whatever. And we use that as training. So these systems, as sensor systems, monitoring people, have some uses. But of course, we're also interested in signaling. If you have a computer in the home, it would be nice if it's had a face that expressed emotions. And that maybe would improve your communication with it. We like talking to people who have expressive faces. Maybe we'd like computers with expressive faces. Maybe. So we commissioned a robotic head from a man called David Hanson in Texas, who makes very fine quality prosthetics. So we have this human head with about a couple of dozen motors, servos inside it, replicating the key muscles in the face. And we can then use that and animate it using these action units to display different emotions. And at least in still pictures, it looks middling to convincing. The animation, I have to say, is a great deal less convincing. It turns out that it's really very hard to replicate the precise movement, the dynamics of a human face. And to make things worse, people are really good at distinguishing failings in the movement of the face, because it's a way that we diagnose somebody's illness. We see that their face is not moving properly. So we're peculiarly well attuned, and people have conversations with this robot. We thought we'd see if it enhanced their conversation when it sort of gave encouraging social signals, and they just find it plain creepy, it turns out. So that was not so good scientifically. We found two uses for this robot. One was actually training medical students to deal with patients with a condition called dystonia. Dystonia is a condition where you get involuntary muscle spasms, particularly in the face, but in other parts of the body. It's very disturbing when you're talking to somebody who has dystonia. And medical students, when they first encounter it, are prone to show disgust, and that's not something you're meant to show when you're talking to a patient. So it turned out our robot is really good at doing involuntary muscle spasms in the face. So we did some experiments where we trained medical students to have conversations with our robot, and some who didn't, and then they met patients with dystonia, and we could see, by monitoring the medical students' faces, the differences in their response when they met real patients. So that was mildly encouraging, only slightly less significant because it turned out showing them a film of a patient with dystonia was just as good. So what's useful about robots, it turns out, is they're really good for publicity. If you've got a robot, the press will flock to your door. So in particular, go back into fiction, and Beth's going to talk much more about fiction in a moment. We go back, and I guess the first appearance of robots, well, if we ignore the Gollum myths from ancient mythology, robots as we perhaps understand them nowadays came in about 1920 with Karel Čapek's Rossum's Universal Robots, which is a fascinating book in terms of its understanding of the difference between humans and human-created, I would say machines, but actually they were biologically made. And of course, also in the 1920s was Fritz Lang's Metropolis, and then Asimov and on in more recent times, even up to Douglas Adams, who of course characterized a robot as your plastic pal who's fun to be with, which may or may not be true. And people are fascinated by these robots. Robot films just keep coming back and back. But actually, as John said in his statistics he was showing us yesterday, these are not the robots that actually dominate in any sense. The ones that dominate are industrial robots, making cars, making integrated circuits. The job of wiring up integrated circuits is now so delicate that people simply can't do it. Working in medicine. These are the main robots. There are also robots in commerce. So things like the global phone system, I would say, is a robot. It's something that has sensor systems that detect inputs, and it has effects in real life. Likewise, satellite navigation systems, and particularly financial trading systems. Anything that takes input and produces output that has a perceptible effect on the world is a robotic system. And actually, these are the ones that we should be worried about rather than the ones that look like people. Arguably, the 2008 financial crash was caused by renegade robot trading systems. And I'm more worried about those. I'm also very worried about military use of robotic technology because they're trying to encode somehow the ethics that normally a trained officer would be exercising about the legality of particular operations in war, and they're just handing it over to machines, which seems like a bad idea. But still, people are fascinated by domestic robots. So they want robots that wait on them at table, perform marriage services. Why? What is it about these that so fascinates people? Of course, even the idea of having relationships of some sort with robots. They think of as human-like robots, but actually, I should say that the relationship that most of you have with your smartphones is pretty weird, frankly. And being separated from your smartphone, I suspect you might find more distressing than being separated from your partner for a day or two. So what is it about human-like robots that's so peculiar? Well, Turing, no, I won't talk about Turing. He was an indifferent computer scientist, but his test is fascinating, but of course it misses the point because it ignores things like social signals, facial expressions, vocal nuances, body posture and gesture. So what is it about robots that we need to worry about? Turing's question about can a machine think is, as Edgar Dijkstra said, is about as intelligent as asking, can a submarine swim? It's just not a meaningful question to ask. In fact, the original paper he wrote when he was working at the National Physical Laboratory, and the director of the laboratory at that time, Charles Darwin, grandson of the other Charles Darwin, dismissed it as a schoolboy essay, and it didn't get published for another 2 years. It's just possible that Darwin was right, that actually it's not really that helpful a paper in the sort of discussions that we're having. So what ethical issues are there? Well, I think what I've seen from the work I do, people think these robots are sentient. Well, they're not. They're systems with sensors, they're systems with servos, actuators, but that's not the same as sentience. These can sense emotions, express emotions, but they don't experience emotions. And in that sense, we have to be very careful about what we what we say about ethical implications. Imputing that these machines have persons is just a category error. They don't. They're no more persons than the lift is, and the lift doesn't get hurt when I kick the door to open it. So the ethical issues are just the same as those of any other profession. It's your motivation. Are you trying to exploit people? That's a bad thing. Are you trying to benefit people? That's a good thing. And your competence. If you write an incompetent computer system, that's a bad thing. And if you write a good computer system, that's a good thing. And really, the ethical issues are no more complicated than that. So the real question is, why are we so fascinated with this idea of robots? Why do we get so obsessed by them? Why are we having this meeting? And I suspect it's something to do with the fact that we're trying to make machines in our own image. But it's a lousy image. It's not a good physical representation. Our robot's just plain creepy to deal with. There's no relationship with it. It's not actually anything like a real person-to-person or creator-to-creation relationship. And they have no empathy. There's no spiritual representation. So our relationship with these robots that we create is completely different from our creators' relationship with us. And I'd suggest that that's actually the interesting lesson to draw from this, that we somehow are trying to make things in our own image. And, well, we were made in God's image, male and female, and if we read the creation accounts, there are two characteristics of why God made us and what our purpose was. One was to rule the world, that's what he means by image, and we were made for relationships. That's what he means by image. So God ruled the world, we are in his image, and we have rule over the world, and God made us for relationships with him, and in his image we have relationship with each other. And both of these rules are broken. We rule the world rather badly, and our relationships with each other, and particularly with God, are broken. And actually, trying to understand where all this is leading, why do we get fascinated by robots? It's just a reflection of those broken relationships. And actually, if we want to try and understand what's wrong here, we need to go back to the cross and see how that sort of relationship can be restored. But that's a much longer story, so I think I'll probably stop about there. The one thing I will just say is, of course, I don't actually do any of this work. It's all done by a team of extremely clever young people. They do all the work. I just come and take the credit. Thank you very much.
Thank you. Well, thanks very much, Peter. And provocative. Basically, your message is we're wasting our time. We should be out there enjoying a nice weekend, but that's slightly overstating the case. Comments or questions?
Thank you very much. You used the word expressing. I was curious about that because expressing generally means to convey a thought or emotion. So I was thinking with these robots, are they actually expressing something or merely mimicking facial expressions that we humans associate with particular emotions?
Well, of course, I meant expressing in the sense of displaying, so exhibiting, showing. No, of course, they don't have emotions. They are just sensor systems and actuators. What you connect them together with is, of course, more computer program. And that's where the ethical issues are inside that computer program. But those are just professional ethical issues of motivation and competence, I would argue. Richard?
What's the computer science interest?
Sorry, what's the...
Well, basically, you said that the credit one might get from this in terms of a new modality for dealing with machines doesn't really run. But so I'm just asking, so in terms of computer science, not leaving aside the topic, the topic of this conference, what's the computer science you find interesting?
Oh, well, the computer science is we can communicate better with machines. So one of the examples that they work with is the idea of a smart satellite navigation system that you might put in your car. You could imagine that satellite navigation systems as they stand are a complete pain. They don't have any social skills. So you're lost in an unfamiliar city centre, there's busy traffic, and it tells you to make a U-turn. You'll probably have an accident. If that system had the social intelligence of a front seat passenger and was watching your face, it could see that you were confused and cognitively overloaded and could actually do more productive things like stop your mobile phone from ringing.
Why don't you show that?
Sorry?
Why don't you show that? Why are you showing cyborgs? Why are you not showing what you can do with the input in terms of new outputs? I'm just asking. I'm not
I see. Why? Well, because people like to see pictures of robots. No, the actual... no, you're entirely right. The serious work that we're doing is... my student, Ranil Kalyubi, runs this company monitoring facial expressions. That's a serious commercial use. We're working with a car company. You won't have a cyborg sitting in the passenger seat of your car guiding you. You will just have a camera monitoring your face and trying to understand social signals. Well, actually, from things like grip on the wheel as well. Yes. I just include the pictures of robots because people like robots for interesting reasons in themselves, I would suggest.
Thank you. Say people like astrologers are good cold readers and probably not often aware of it themselves. Are we developing robots that are just good cold readers?
Sorry, good?
Cold readers.
Cold readers. Oh, yes. So reading body language and social signals in the face and tone of voice. Yes, that's very much what we're trying to do, but that's part of human communication. So it seems reasonable to try and have computer systems that share that ability.
Would you say, you had one sentence, I think, on the penultimate slide, where you said that it's a category error, I think.
Yes.
Would you say that a lot of the questions we are discussing over these 3 days actually are category errors?
Well,
Not all of them, of course,
He's such a
but many
polite
of them.
man. He really wouldn't
Yes.
want to say that, but that's what he believes.
no, because I think they help us understand broader problems, and but we shouldn't make it as narrow as are we going to have sentient robots taking over the world? That's not a useful thing to do. You just pull the plug out and typically they stop. But to understand that there are ethics involved here, and there are, after all, if you can automatically monitor somebody's mental state and influence it through actuators, you are in a very powerful position. And what I'm saying is that the ethical issues I see there are just standard professional ethical issues. So, for example, Facebook, did this experiment where they filtered people's news feeds to give them either positive valence or negative valence stories, and then monitored the resulting postings by those people, and saw that they were actually able to change people's moods. I think most people would regard that sort of activity, that experiment, as unethical. Facebook said, we had consent. I don't think any ethics committee that I've worked with would regard it as informed consent, and I think Facebook actually accepts that now. So, yes, there is an important ethical issue there, but it's just a professional ethical issue.
I think we should probably move on, as we're slightly short of time. So just let's say thanks again to Peter.